Hi kids, I'm Bing Wu, and I have a cookie problem.
Hey, I can help you solve your problem. Let's figure out your constraints.
Well, I have 480 pounds of cookie dough, 48 pounds of chocolate chips, and 24 hours to bake as many cookies as I can.
Well, how many pounds of cookie dough does a batch of plain and chocolate chip cookies require? And how much time does it take to bake each? How many pounds of chocolate chips do you need?
Well, Bing Do, plain cookies require 2.4 pounds of cookie dough and 2 hours of baking time. Chocolate chip cookies require 1.2 pounds of cookie dough and 0.48 pounds of chocolate chips. I make $50 off each batch of plain cookies and $65 off each batch of chocolate chip. So, how can you help me solve this with math?
Hey, the cookies are ready!
First, let's write down our constraints. Next, we can solve our constraints for their extremes. This is done by setting one variable equal to 0 and then alternating. Now you can graph the extremes. For example, take both extremes from one equation and plot them accordingly. After graphing, locate the corner points. Any corner point that is located on the x or y axis can be determined without calculations, but any corner point without definitive location must be calculated using the two equations whose lines form that point. Don't forget to plug the corner points back into all the constraints and check for extraneous solutions. Finally, the objective function. Since Bing Wu makes $50 off plain batches of cookies and $65 off chocolate chip batches of cookies, Z is equal to 50p plus 65c. Then plug in the value corner points, the ordered pairs that yield the highest value if you're maximizing, or the lowest value if you're minimizing is the optimal solution.